Hi everyone, and welcome to the intelligent world. Say hi in the chat, let me know where you're from today. I'm from the Netherlands, and today's deep dive is about the soft robotic gripper. Now, let's start. This is the intelligent world. We have again an amazing innovation today. It's a soft robotic gripper, and it's pliable, it's gentle enough to handle all kinds of different objects delicately without even damaging them. And it can pick up, for example, a wine glass. It can pick up a piece of fruit, or it can even pick up a smartphone. But this gripper is also strong enough and sturdy enough to grasp heavier objects, and it can lift even 100 times its own weight, which is, I think, quite remarkable. And therefore it can lift power tools, or it can even lift a shoe, which are, let's say, a strange type of format. You name it. Now, let's watch the full video. Now let's explain in a little bit more detail what you just have seen. It works by creating a vacuum that collapses the gripper. And the fabric-based type of design is fit around an origami-shaped type of skeleton, and that can really tighten around the object, and when the vacuum kicks in, and then it sticks. Now, this is when things start even to get more interesting, I think, if you look to this type of technology. It's really difficult to program and to code a robot to move and to perform this type of task. It's very unstructured process, and the robots really have difficulty operating with all the different kind of uncertainties of the format and the shape of the object. So think about this robot gripper as picking up an object from all different kind of angles, or objects with all kind of varying shapes and all different kind of varying weights. And I think this is even beyond difficult in what you see over here. And manually programming such a robot to do that, it's totally out of the question. But in this type of let's say part, scientists have added tactile sensors, and they're added to the device, to the gripping device. And the gripper, they can now sense what it's picking up, and it can classify what it senses. So that makes, really sense. And the robotic gripper learns and understands what the object is by picking it up, and doing even a better job every next time. So it's self-learning, and that's amazing. And I think it's needless to say, robotics is becoming more advanced than ever before, and will advance very fast in the near future. So scientists, they are searching for all kind of ways to innovate in the robotic design, in adding all kind of new features, new functionalities, and all different kind of industry applications. And data and artificial intelligence capabilities, they are being combined with this robotics to increase their movement and the operational capabilities. So just like how this robot is equipped with this tactile sensors, that's exactly where AI is in action. Now, think about how these type of robotics can be applied to all different kind of industries, for all different kind of various applications. Now, like how these type can be used in a factory production line, for example, to pick up bottles. This is just one of the examples. What I would really like to know is, what do you think that this type of robotic grippers would be good for in different type of industries? Can be B2B type of industries, but can also be B2B type of applications. Let me know in the chat what you think, what this can be used for, or maybe you have even suggestions and it's not existing yet. Now, if we look to the efficiency in the design of this gripper, it's pretty remarkable. So the materials and the fabrication enable the creation of this new type of customized robotic gripping designs. So anyone can use this type of approach, and you can create all different kinds of styles and all different kinds of size of grippers and use them for all different kinds of new innovative purposes. You can design them yourself. And this robotic gripper, has some kind of core purpose. It's really a design that improves problem solving for different type of robots. And the tactile sensors, they can classify the objects with almost a 90% accuracy. Now, if we look a little bit more into the future, the same team who built this device, which is the MIT CSAIL team, and thanks for sharing this type of knowledge and this type of new innovations, they hope to add computer vision to enhance the different type of angles and the different type of orientation, problem-solving capabilities as well, to make it even smarter, better, and then stronger. And in this case, the robotic grippers, they could then see the objects and they can learn how to pick them up from the different type of angles. And it becomes more smarter the more it's used. Now again, I have another question for you in the chat, but let's first see what kind of applications you have in mind. We see Zach, we see Mahavir. Mahavir, maybe you have some ideas how to apply these applications. Zach, thanks, it looks cool. I totally agree with you. And yeah, it will be a game changer for the fast-moving consumer goods. And especially in the fast-moving consumer goods, you can, on one hand, think in, let's say, vegetables, which are very sensitive type of products where it's used in this retail and in other retail applications, especially in the supply chain. This is exactly where these type of grippers are used and where they work very well and change the supply chain, the collection from the objects and the products, and put them in, for example, the boxes. Now, if you have more ideas, just let me know in the chat. I want to thank everybody for joining in today. If you have an amazing innovation, if your company has great innovations, just direct message me on any channel. You can easily reach me, and maybe you are next time in this broadcast as well. Thank you for watching, and this is The Intelligent World, and we see you next time.